Hi, in today's video, we're going to be working some examples and dealing with derivative rules. If you haven't checked out my previous videos, take some time and look at those. In 3 different videos, we take a look at all the rules. So in this video, we're just going to work some examples that you might get in your homework or maybe in an exam. And they might look tricky, but they're actually fairly easy to work with. So let's get started. Notice this function is in a fraction form. The problems that we're going to be working with today, they sort of require you to rewrite the function in a different way so that it makes more sense. The way that it looks now, there's really you can't really make sense on how to get the derivative. So another thing you can do is rewrite it in a different way. And math is about that you can rewrite functions that look easier, that'll make it easier to solve it. So all the functions we're going to work with today, we just have to rewrite it in a certain way that makes more sense and it's easier to get the derivative. So now that we rewrote the function, all we have to do is get the derivative from this section here. And notice how it looks a lot easier doing it from here than having to go through some kind of weird process here. Before we continue, just remember that this problem here is, you have 2 different things going on here. You have the constant, so just remember the constant multiplies along. So in this case, you will have to get the derivative just from within the parentheses. And this section here, it's the power rule. Just remember that the power rule, the exponent moves to the front, and then you take 1 away from the exponent. Okay, so this here, it's your derivative. This is your answer. Now, even though this is correct, there's another step you can do to simplify it. I don't know if you leave it like this, I don't know if your professor is going to count it wrong, give you partial points, but really the right thing to do here is make it look like the way it started at the beginning. So in this case, we have to move the variable with the exponent to the bottom, to the denominator part. Okay, so now we've completely simplified the problem, and this here is your answer. This is what your answer should look like. Remember that the first thing we got to do is rewrite the problem, kind of like we did on this one here, so that it becomes easier to work with, and it becomes easier to get the derivative. Now that we wrote the function in a different way, notice how now it looks a lot easier to work with, because now it looks like one of your basic rules. Once we have the derivative, we notice that we applied the power rule. So move the exponent to the front, take 1 away from the exponent, and this is what we get. Same as this problem, this is your derivative, but it's not fully simplified. And finally, this is your answer. This form and this form it means the same thing, but this is your more simplified version. So this is what you want your function to look like. On this problem, we're going to do the same thing as this one. Just rewrite the root in a different form. And then once we do that, it'll be easier to get the derivative. Notice here how this looks same as this one here, but because here we only had 1 variable, here you had to apply the power rule. In this case, we have a full function within the parentheses. So in this case, you have to apply the chain rule. Okay, so now we've applied the chain rule. Remember, move the exponent to the front, take 1 away from the exponent, rewrite within the parentheses, and then multiply that times the derivative of within what's inside the parentheses. Okay, so now with this problem, remember, same thing as the other ones. You just have to rewrite it to where it becomes easier to try to get the derivative. So the one thing we can do here is, if we separate the x squared, we can move that to the top, get the derivative for that, and then put it all back together. Now you can see that you can work with this. This has become a constant. So now you can get the derivative from within the parentheses. And once you're done, you can put it all back together. Just as the other functions, this here is your derivative. So the only thing you gotta do is just simplify it further. And the only thing we can do here is move the variable to the denominator part. Okay, so now that we've simplified it, this and this is the same answer, but this is the form you want to have it as, just in case your professor, or if you're doing an exam, just in case the problem asks you to simplify all the way through. Okay, this problem here, as you can see, is a combination of a regular function and some trig. So here, you want to be able to look at the parts separate. You know, here you're working with a couple of different rules. So you want to be able to know what they are so that you know what steps to follow. The one thing we can do here is, same as this problem here, is separate this part, the denominator. On this section, all you have to do is get the derivative for cos x. But notice here that your denominator is within the parentheses and then the exponent. So this and this is two completely different things. The exponent here is on x, not on 3. But here, since it's in parentheses, the exponent is on both. As you can see, there's a huge difference from this here to what the problem looks like here. Because in this case, you also have to multiply the constant times the exponent, as well as the variable times the exponent. Okay, so now that we simplify the problem more, we move the variable to the top, simplified the 2 with the exponent, and simplify this section here too. Now that we have the derivative for x, all we have to do here is simplify this section. So we're going to multiply the constant times -3 and just continue to write this down. And we're going to move the variable down to the denominator part. Okay, so from here, as I mentioned, we multiply the constant. So you get -15/8. And then we went on and moved down the variable with the negative exponent to the bottom, which becomes a positive exponent. And we just continue to keep -2 sine x and just moving it down. So these are just some of the other problems that you're gonna have to deal with when working with derivatives. If you haven't had a chance, take a look at my other videos where I work basic problems that deal with the derivative rules. Even though they're basic, I try to break it down to where it makes the formula or the rules understandable so that you can learn how to apply them when you take a look at the problems that you're working with. Some of the problems that you're gonna encounter, they may look difficult or confusing, but if you know what you're looking at, you'll be able to know how to break it down to where it becomes easier to simplify. If you like this video, give us a thumbs up and don't forget to subscribe.